Okay, means that if you have a marking scheme or marking the marks provided for this task is about 10 marks. Okay, 10 marks. So means that the allocation of mark is like this. So you have 2 marks here provided. So you analyze, you give the data, you have the trend. Means that you can comment. The result is that this device can conduct up to 11.59 ampere. So you should get 1 mark. 1 mark for the comment. You can write over here. So this is example. Maybe you can write in terms of how much the maximum current, but the trend is that it can conduct up to 10%. Or you can write the maximum current that it can conduct is about 11.59, but and this amount is about 10% or 11% of the rated current of 120 ampere. So 2 marks here. One is regarding the data, one is regarding to indicate your trend. Then the other is that you have the mark for answer. You have mark for your steps. You have mark for your formula. So 1. So we have 5 over here. So 1 mark for answer, and maybe 1 mark for your step, 1 mark for your formula. See? So then 1 mark for your method to find this RDS on, and 1 mark for your concept, and maybe we have 1 mark for your what's so called your effort to find this data from the datasheet, and this data from the datasheet. So we have mark for that, and you know where to extract the data. So how many marks are there here? 1, 2, 3, 4, 5, 8, and 9, 10, like that, and 10. So we have 10 mark here for your task of question number A. Thank you. Then we go to B. So we have B here. So now you are being provided with a individual heatsink. You know, I told you before, if you have a device, so individual heatsink means that each of the device will have their own heatsink. So one device with one heatsink. It's not a common heatsink. Common heatsink means that one heatsink we put maybe 2 or 3 devices here. So this is common heatsink. Meanwhile this is individual heatsink. So if you have individual heatsink of 4 degrees C per watt of their thermal resistance, thermal conductivity, and you have thermal pad of 0.5. What is thermal pad? Is the element that we have between your device and your heatsink. So this is your thermal pad or thermal paste. So reevaluate on your observed improvement. Means that previously we have calculated that we have 11 point something ampere in terms of the amount that the device can conduct, and it's now 11.5. So now we put a heatsink on the device. So what you have to do is that please redraw the concept and draw nicely such that you can refer or you can note the data on that. So again, please jot down all the information here. So we have here TJ, TA, in between we have T case, T heatsink, and here is our R thermal from junction to case. Here is our thermal. So draw bigger such that you can label properly. So TJ just now is 90 degrees per T ambient 30 degrees C. After you draw, you just note down all the data here. So what else here? We have PD and draw and label, and for sure later you have 1 mark for that lah. And even though not mere request, but you show the concept, there should be a mark already. Then label all the information that given. We have heat sink of 4 degrees C per watt. So just now we have here 4 degrees C per watt, and RJC here, and sorry, this one, heat sink provided. CS here, thermal pad 0.5 degrees C per watt. RJC is available in your data sheet. Okay, where is your data sheet? Please open your data sheet to see what is your RJC. So go and take a look on your thermal characteristic, and thermal characteristic, which is here we have here RJC, junction to case of 0.6, no other F. See, this one is junction case to heatsink. The grease surface assumed to be 0.5. If you put the grease, you can use here, but we have been provided with thermal pad, so which is the same amount, so no problem, use thermal pad value. Now RJC is 0.6 and RJC is 0.6. So right here RJC of 0.6 degrees C per watt. Then what else you need to do? So we have jot down all the data, and now just write down your formula. Before you start to calculate, what are the related formula? So Tj is equal to Pd R thermal Jc plus R thermal Cs plus R thermal Sa plus T ambient. So this is the generic equilibrium formula should be abide by the device which attached with heat sink. Okay, so you can label this as 1. Another formula that involved here is your PD is equal to I square RDS on during 90 degrees C. Okay, just now you have obtained this value. You can rewrite here that you have not calculated yet, so you can calculate and you state it over here, which is 7.2 milliohm. Sorry, milliwatt. Not milliohm. Power is in milli, and so power is in watt. So milliwatt. So your PD is in milliwatt. 7.2 milliwatt. Oh, sorry. It's not 7.2 milliwatt. This is 7.2 milliohm of your RDS on. 7.2 milliohm of your RDS on. So PD like this. So but RDS on 90 is 7.2 milliohm. Okay. So you go back to number 1, which is, so Tj is equal to PD R thermal Jc plus R thermal Cs plus R thermal Sa plus Ta, which is equal to, or you can write down here, put in all the data. PD R thermal Jc, we have 0.6, and we have obtained up above there 0.6 here. So R thermal Cs is 0.5 being provided. R thermal Sa is 4, ambient is 30. So this is the PD that we have to calculate to get or to know how much actually the current of this one can be conducted when we use heat sink. So 90 minus 30 equal to PD times, we have plus or total up all the values inside, you have 5.1. So PD here is equal to 11.65 watt. So actually this is your PD max. You can label here as PD max. Why it was PD max? Means that this is the maximum dissipated power from your device, such that your junction to remain at 90 degrees C. If you increase this PD or the dissipation values is increased or bigger than this 11.65, so your TJ will increase further. See now, if your PD increase, what happened to TJ? TJ will also increase. You exceed 90 degrees C. Okay, so this is your PD max. So then this PD max, you go to back to number 2. PD max is equal to I square R RD S on at 90 degrees C. So PD max 11.765 equal to I square RDS on, you have calculated just now, which is 7.2 milli ohm. 7.2 milli ohm. So I square is equal to 1633. So I is equal to, where does it gone? So I will become how much? 40.42. Okay, 40.42. Okay guys, sorry, my device just ran out of battery. So the final is that you shall get 40.42 ampere of your I maximum. I max is 40.42 ampere. But if you use another value of typical maximum RDS on, you will get 36.15. That one also correct. But I just discussed for one parameter lah. Okay, then what is the comment that you can get, or you can write here? So what is the comment? So the comment, like what I told you, one is that the value, and it is your trend. So what is the value that you should write here? So the value is that, so the value, so you can say that the capability of device can now conduct maximum current, rightfully ya, dengan buat short term je ya, of 40.42 ampere, but still which is 50% or 40%, which is 50% or 40%, 40 over 120, 30%, which is 30% of its rated value or rated value. So here now you can see that we highlight in terms of number, then in terms of their trend. So you can write any kind of term or explanation as long as we have numbers or data or fact, and we have a trend, valid fact and valid trend. So you will get 2 marks out of this comment or discussion, short discussion. Okay, so that's done for B. Then we go to C afterwards, inshallah.